Okay, good morning, all. Today we are going to have a session on choice. In fact, uh, this is about this is part of the earlier lecture, which is in continuation of what we have done in the earlier lectures. We had already come across with preference, then budget constraint, then pricing, the utility, and now out of all that three, we can now form choice because earlier you have to have a preference a pattern or a bundle of commodities or choices different choices are supposed to be there, which is known as the preferred sets, which is available to you. And then out of then you need to also have to have sort of income or budget that is essential to buy. Then also the third one is the utility that will should have to give you a usefulness. So now you have all these three, just like what the definition of demand and supply says. When you have a demand, if and only if, or somebody can say that if there is a demand, if and only if there is an ability and willingness, as well as the usefulness of the resources. And then only you have demand. At the same time, the supplier also has to have, he or she has to get a reward, a mutual reward. So the ability has to be reversed in that sense. So now all that is given, and now all that been talked about, then we can say that let us have which one you want to choose out of it. So this is what this comes under the choice now. So preference, budget constraint, and utility makes a person, a consumer, to choose. Okay, in a simplest way. So this is one of the most preliminary understanding one should have to have. So now for that you have different economic rationality, and the principal behavioral postulate is that a decision maker chooses its most preferred alternatives from those available to it. This is what we have seen in the preference set, or the lecture on preference. And then the available choice constitute the budget sets, which is what is in the last lecture, which we talked about. That is, for that you have to make your preferred sets as well as your budget possibilities to include those preferred bundles inside your budget. And how is the most preferred bundle in the budget is being located is what is known as the choice. So normally this is in that sense called the subset or the ideal set, or within the preference set. So this is what is something in a simple sense, narrow sense, we can actually attribute to. So rational constraint choice in that sense is clear. It's especially just like this is a budget line. So the budget line says in the last lecture, it is clear that when you have an income of m, then you buy x1 and x2, all right, or a combination of x1 and x2. Or either if you like to have one commodity, then it implies that the other commodity have no value. So it will violate the utility condition, as well as making a commodity inside your preference, because since it is talked about the individual, specifically an individual's preference and his likes regard his or her likes regarding the commodity, then if you say that x1 has no value, then it is needless, it is redundant to in fact include that in your two-dimensional vector space, because in that case your vector space is only a single vector. Okay, in that so it is not a two-dimension, single dimension. So that is not going to give you this kind of a graph, because it is clear that whatever money you have, you are going to spend on one commodity. So there is no choice involved in that. So that is what you have to have a budget constraint, which is talks about at least two commodity, x1 and x2, and a combination, and both the commodity gives you a positive level of utility. This is what we discussed in the previous lectures. And now when you talked about the utility of that kind, now if you add your commodity and the utility, then it becomes a three-dimensional space like this. Now you have, of course, in two-dimensional case, you have a budget constraint, and that budget constraints gives you a level of utility. And if you have different combination, indeed it is going to give you different kind of things, which is as mentioned in this graph. When utility, the green portion says that, or it indicates that higher and higher level of utility, as or we mentioned in the earlier case. Okay, so when you corner that as in the to make it as more clear. Now this is actually the portion which we are dealing with, one, two, three, and now that one, two, three, that combination, that is the affordable combination, is belongs to that particular thing, and out of that the best is actually going to lay on the upper portion, and affordable but not the most preferred affordable bundle. That is what we been indicated with that diagram. But at the same time, if it is in the top, the most preferred of the affordable bundle, it's within the affordable bundle, you have this thing. So this is in the three-dimensional case. So this is roughly what we are actually dealing with. So when you have budget constraint, then you also have different higher and higher level of utility in different curves. Gives you higher and higher level of utility is being understood in this slide. Okay, so one will choose the bundle on the outermost indifference curve. Therefore, it is the one that just touched the budget constraint. So the tangentiation and all the things. So if you see that, in that is what is actually we are envisioned or been depicted. Now that has been put into the simple two-dimensional textbook type graph. So in that, now you have an x1 and x2 star, which is the optimum case and is the most preferred affordable bundle in that sense. So now the most preferred or affordable bundle is called the consumer's ordinary demand. So at the given price and given budget, this is what is known as the ordinary demand. And ordinary demand will be denoted by an x1 star p1 p2 m and x2 star p1 p2 m. So when x1 star is greater than or equal to zero, greater than zero, that means your x1 is strictly gives you a utility which is positive, and x2 star is also gives you a utility which is zero. The demand bundle is interior, and you also know that it will never touches its axis. This is what sometimes people studied in your basically undergraduate level, and also it never touches because it is interior. So if buying x1 star and x2 stars cost some amount which is called the $, then the budget is exhausted. So if you say that both is actually going to constitute the total $, which is what you have, then that kind of situation is what is called the exhaustion of your income. Okay, so assuming a monotonicity and smooth indifference curve for an interior solution x1 and x1 x2 stars is satisfies two conditions. See, these are the most important thing, and in fact we had talked about this in the earlier thing. The budget is being exhausted, that is p1 x1 star plus p2 x2 star, which is equal to m. That is what is actually known as the exhaustion of the income which you had, or whatever money you have. In a simple sense, whatever money with you is being spent for the commodity which you are going to buy. That is in your preferred set, some commodity combination of x1 and x2 are going to be bought and being exhausts your income at your hand or disposal. So this is what was point number one indicates, and B indicates that the slope of budget constraint, that is minus P1 by P2, and the slope of indifference curve containing x1 x2 stars are equal at x1 and x2 stars. Okay, so this is actually simply says that the dy dx2 by dx 1 is equal to the marginal rate of substitution, which is equal to the marginal utility of first commodity divided by the marginal utility of second commodity, which is also equal to P1 by P2. So this is condition we can be normally written in any textbook. If you look into, actually you will get this, this equation only, dx2 by dx1, which is equal to MRS, which is also equal to mu1 plus mu1 by mu2, which is also equal to P1 by P2. This is indicates that simply the budget set is being exhausted. These two conditions being actually satisfied. So the budget is being exhausted, as well as the slope of the budget constraint and the slope of the indifference curve containing are equal. So that means it is optimized given this situation. So at the optimal choice, the original willingness to pay for an extra unit of good 1 in terms of good 2 is the same as price you actually need to pay in that sense. So if the price is lower than your willingness to pay, you would buy more, otherwise buy less. This is what we try to indicate through this particular expression. Adjust until they are equal, otherwise it will adjust until they are equal. So this is what is this marginal rate of substitution, or the P1 by P2 P1 by P2 combination try to figure out. So when you say mathematical formulation in the form of mathematical formulation, this is exactly looks like, if you look into variant, you see this equation. So the consumer problem can be formulated. They don't tell you all this in detail and all. So it is imply that you know this, right? So the consumer problem can be formulated mathematically, therefore, as maximization of x1, x2. So our objective is, in the beginning, as we said, a rational individual maximizes. One of the criteria of rational choice was maximization. So in that sense, you have a maximization of x1 and x2 such that your utility from x1 and x2 is indicates of p1 x1 plus p2 x2, which is equal to your m. So now this expression is a simple expression, that is the price of x1 plus price of x2, which is equal to your m, that is your income or disposable income. Then it implies that whatever commodity which you are going to speak or we are speaking about is being exhausted, and that's it, end of the story. Now if you say that somebody has a doubt on it whether that is true or not, then what you would normally do in mathematics, you introduce a constant, or some k or lambda. So then you see that whether that is changes anything or not, given it is actually exogenously determined, and that exogenous variable you introduce, and you see that whether this x1 x2 has any change, because it is going to have a fixed effect. So this lambda is a fixed coefficient normally. So one way to solve, therefore, in mathematics is actually introducing a Lagrangian method. So a Lagrangian method is nothing but you introduce a constant in that sense and see that whether that is having any influence on the proposition, that is p1 x1 plus p2 x2 is equal to m. Has any difference, or that means it is whether that is going to be not equal to m. So this is what is you want to check with. So L is equal to, in that sense, ux1 x2 plus lambda m minus p1 x1 minus p2 x2. So this is what is the standard expression normally using. So there is a lot of procedure, Lagrangian procedure. If I teach Lagrangian procedure, then that would be a different class. So the mathematical economics, you will learn that. So I mean, of course, this is the sum and substance and the spirit to see that whether that is having any sort of an influence really in the initial proposition which we made as p1 x1 plus p2 x2 is equal to m. So this is why we need to basically see that whether any disruption or fixed disruption, if you introduce, whether that is going to change anything on the other. This is what is I would like to understand this simple terms. This is making things more clear, but normally we see that because of this too much of notation and all interference of this procedure, we feel we always misunderstand or mislead. because we feel that it is complicated. So nothing of that kind. Simple. This is only for to understand whether there is any disturbance possible. No. When you have a deductive logic, see, in the beginning, as I said, when you apply a deductive logic, you should know, and you should always, go for either a consistency, or it should be in the backward and forward induction should give the exact same result. That is what is the deductive logic's demand. So in that sense, this is important, to introduce any constant and see that there is no disturbance, and it should be the case. So this is the beauty where you seek help from the mathematical uh, side. So that is why I am simply trying to say. So you try to understand it with your mathematical economics lecture, with that of any economic theory understanding. So I am not going to anyway discuss on that. So assuming the utility function is differentiable and there exists interior solution, the first order condition therefore is the following. What is the first order condition? The change. Okay, so this is what is called the first order condition, and the change is what is called the second order condition. So the first order condition in that sense is dou L lambda with respect to the x1. Now here dou means it is a partial differentiation model, and it is not actually the full differentiation model, or what you call the effect is always been understood in terms of keeping other things constantly ceteris paribus. So that is why you have a dou function that is partial change, whether that is having with that of the change in the constant. So dou L by dou x1 is equal to dou u x1 x2 by dou x1 minus lambda p1 x is going to be 0. This is the assumption. That means there is no disturbance whatsoever. So that is why you always have this equal to 0. So there is no disturbance in that sense. So if you keep proceeds the same mechanism to the other commodity, then also you have this thing. So therefore, in sum and substance, what we try to say, the change in L with respect to the change in lambda, which is the constant which you universally apply to the variable or the commodity x1 and x2, then it will not have any effect, like a minus p1 x1 minus p2 x2 is exactly going to be 0. That means there is no change whatsoever. It will be uh, introduced. So because of that introduction. So from the first order condition, we have this uh, dou u by dou x1 by dou u by dou x2, which is equal to p1 by p2, which substantiate to the first expression, which in the right side expression, the last expression, that is p1 by p2. So which is the same as marginal rate of substitution. Now when we in the earlier lectures also we have seen that MRS is equal to p1 by p2. So what we are trying to make by introducing a constant also, there is no change. So we have the same condition as before, that MRS is equal to price ratio. So this is what is normally one can say. So for interior solution, we can solve for the optimal bundle using the two conditions. That is, you have a dou u x1 x2 by x1, a whole divided by again dou u x1 x2 x2 with respect to x2, so which is equal to p1 by p2, and then it is equal, so p1 x1 plus p2 x2 is equal to m, which is the original expression of exhaustion which we had talked about. Now when you have again computing ordinary demand, a Cobb Douglas example, things are going to be again understandable, and it would give you more clarity in that sense. Suppose that the consumer has Cobb Douglas preference. What is a Cobb Douglas preference? We have already seen the ux1 x2, which is equal to x1 alpha and x2 beta. So then mu1 is equal to dou u by dou x1, which is equal to ax1 alpha minus 1 and x2 beta. So or what you say, that alpha minus 1 minus beta. So you can say that. Okay, so mu2 is equal to alpha and x2 beta b minus 1. So this is because of the this partial differentiation, and so the marginal rate of substitution is going to be exactly the same. That is MRS equal to dou u by dou x1, which is we have already seen, with dou u by dou x2, which is equal to. Now, what is actually the ratio is in that sense a fixed effect. That is, your effect cannot be greater than one. So one and my a minus 1 and b imply that it is having a fixed proportional, basically fixed proportional change. That is, utility can vary between 0 to 1, but that 0 to 1 is in fact being assigned to either x1 or x2. So that's it. So there is a fixed effect which is assigned to in a variable fashion between x1 and x2. That is the idea. That is what this third expression says, and ax2 by bx1 is the result. So at optimal case, that is x1 star x2 star, we had that is the tangential point in the graph which I was shown, where MR is equal to P1 by P2. So what we are trying to say that once it is an optimal, so you are trying to indicate that with AX star 2 by BX star 1, which is equal to P1 by P2. In fact, that is P1 by P2, P1 star by P2 star, which is again implies that X2 star, which is equal to a bp1 by ap1, that is beta p1 by alpha p1 times x1 star. Okay, x1 star. So this is what is actually we try to make in the earlier propositions. Okay, this is in tune with what we have seen in the earlier expressions like this. Okay, so now we know that all this has been given for alpha and for beta, and the last one p1x1 star plus p2x2 star is equal to m is exactly what we start with. So, and if you simplify, then for a Cobb-Douglas case, you can say this equation like x1 star is equal to alpha m by alpha plus beta p1. Okay, so substitute for x1 star in p1 x1 star, then you can again improve that point in this form also. So a p1 x1 star plus p2 x2 star is equal to m, then gives x2 star, which is equal to bm. This is for the second commodity. So a plus b, that is alpha plus beta p2, you will also get. So that is why you have now two different things, which is we said. So we can discover that the most preferred affordable bundle for a consumer with Cobb-Douglas preference is the following, like ux1 x2 is equal to x1 alpha and x2 beta, which is expressed as we found out in the earlier proposition, like this thing, as in the following format. That is, x1 star and x2 star is equal to alpha m by alpha plus beta times p1 and beta m by alpha plus beta p2. So this is what is your equation. So this is exactly what has been seen in the graph, which is now normally. So why, you may be wondering now, that why all these things? See, it is very interesting when you see a graph, you should know all these things. These are the process which is it's been derived, and when somebody say that there is a point in a two-dimensional vector space, and that is a choice point, or you say choice set, a combination of x1 and x2, so you should also know that that is basically had all this property which we said, all the mathematical derivation which we can. So when you say that this x1, you can simply apply all the u and x1, ux1, x2, which is equal to x1 alpha and x2 beta. which is also equally the point which is we have tried to in the x2 axis. X2 star is given, that is at the point, blue point, which is the tangentiated point of our curve, that is utility curve with that of the budget constraint, is what is exactly this expression, that is Vm by alpha plus beta P2. At the same time, the same is applicable in the x1's case also. So x1's case, x1 star is equal to alpha m by alpha plus beta P1. So this is what has been given. So this is what we have so far tried to derive. So people may be wondering why we need it. Straightly you can say this is whatever, whether I am deriving it or not, exactly this is involved this kind of thing situation. Okay, so with the optimal bundle, let's the utility function has the same. So x1 star x2 star is equal to em, that is alpha m by alpha plus beta P1, and for the other commodity also the same. Note the expenditure on each good, you can see this thing. So you can say that P1 x1 star and P2 x star x2 star is having a given case like this thing. So you have an alpha by alpha plus beta times m, and or you can say that a beta plus by alpha plus beta m. It is a property of Cobb-Douglas utility function. So this expression is exactly this property. This is one of the important properties of the Cobb-Douglas utility function, that expenditure share on a particular good is a constant. So you cannot simply say that it will vary. No. Now, in this case, it is not that. So in this case, it is only one point you can have this, not on the other points. So only one point in this kind of situation, you have only one point which satisfies this combination. Okay. Now, this is what is called the kinky tastes of people. So at one point only they will be liking it, but not other points. So there is the substitutability question is always made in this case. Okay. So again, a special example which try to give you about the more than one tangency point. So suppose if some people say that so you have a utility which is not actually well behaved. This is not a well behaved utility because it has different ups and downs in the same curve. So if you apply the tangency condition of indifference curve with that of your budget constraint, now you say that the third curve having a trough, that is 2 points, that is exactly exacting with the second utility indifference curve, that is that non-optimal bundle. That is actually by definition we used to say that in a higher and higher utility curve gives you higher and higher indifference. So though there is a tangency condition, but two different indifference curves in fact passing through the same budget constraint gives you different ultimately different results. So the tangency condition is only necessary but not sufficient to say that. So in this case tangency is there, but at the same time the tangency condition is not sufficient to say that you will go for the second one. But the second one, going for the second one by your definition says that you are actually not good at, but you will move to the third. But going for the third, it is equally to make the point that even the second is having the same uh, kind of thing. So there can be more than one optimum point in this context, and strict convexity implies a unique solution. Now here there is no strict convexity, therefore you don't have a unique convex unique solution. Okay, this is also very important, the convexity condition, and especially in the argument of equilibrium, the uniqueness of equilibrium case is something to do with this point. Now, in this case, you have no unique equilibrium, because now you say that the higher indifference curve and the lower indifference curve gives you exactly the same result, and that is a contradiction, in fact. Okay, so this is about that, and then let us move towards other problems of the same, like corner solutions. But what if x1 star is 0? So this is, I was referred in the very beginning itself. So when you say that you have x1 and x2, but x1 and x2 in the bundle, but some commodity of the x1 or x2 is having no utility. Say the utility, the x1 is equal to 0. So now, in that sense, you will completely go for the other commodity. Okay, you never buy this commodity because you have no utility for the x1. So that results a corner solution. So you, what is a corner solution? You end up at the most, and you, whatever income you have, you spend for that commodity completely. So, or if x2 is 0, then same the case, you will move towards the other end. So if either x1 and x2 is 0 or x, then the ordinary demand x1 and x2 is at a corner, and the solution is also at the corner to the problem of maximizing utility subject to a budget constraint. Example, it happens when indifference curves are too flat or as steep relative to the budget line. Now this is the case. So in that case, if your budget is small, then what you do, you try to maximize your x1, because x1 gives you the ultimate combination in that sense. So the indifference curves are too steep in this case to touch the budget line. The willingness to pay for a good 2 is still lower than the price of good 2, even when x2 is 0. So this is what is called the corner solution or boundary of optimum. Now, the mathematical treatment for the corner solution is more complicated in this case. So we have to consider also the inequality constraints, that is x1 is greater than or equal to 0, and x2 is also greater than or equal to 0. We skip these details here because it is again difficult to establish, but it is commonsensical to understand, and the graph is sufficient, because you feel a little bored if I'll speak much on that. So that is what I'm skipping it. Now, when you have the marginal rate of substitution is equal to 1, so they look at it in this case, the slope, you will always go for the higher case, and your slope p1 with the with p1 by p2, with the p1 is greater than p2, then you will go for the upper end, because that will give you a higher level of utility. So again, your x2 star is equal to m by p2, which will give you a higher level of utility, where you the purchase of x1 commodity is 0, where you, the entire amount you will spend on the x2. Same the case within the other context also. If you have a budget which is trying to be like this, a flatter curve, or in the earlier curve, a steeper curve from x-axis, x1's point of view. In this case, it's a flatter one, so x2 is equal to 0, whereas x1 star is equal to m by p1. That is the complete amount with your pocket you are going to spend for x2. In the earlier case, with x1, with the no x1, so x2, and vice versa. So examples again for the perfect substitute case, when you have a utility of x1 which is equal to x1 plus x2, the most preferred affordable bundle x1 star x2 star, where x is the following, that is m by p1 and 0 if p1 is less than p2, and the reverse is the case when p1 is greater than p2. So this is what is actually the thing which we had tried to explain it or discuss. So this is the slope. All the bundle in the constraint are equally the most preferred affordable when p1 is equal to p2. So in this case, the substitution is a perfect one. You basically, your slope in this case is exactly the same. Therefore, p1 by m by p2 and m by p1 is going to be exactly the same. Therefore, any point at this case you will buy it. So Now, if it is comes with a non-convex preference case, then you know that non-convex case, if it is goes upper and upper context, it is always a better and better solution in that sense. So in this three case, you have actually different thing. One is a tangentiation condition, though it's necessary but not sufficient. At the same time, you will go for the upper one, which is actually on the extreme third concave curve, and it touches there. So where your corner solution in that sense, this is also having a corner solution. In the second commodity, second indifference curve case also, that is concave indifference curve case also, they have a corner solution if you prefer x2 more, and in this case it is x1. Okay, so the most preferred and affordable bundle in that case is, by definition, is actually the green point node. Notice that the tangency solution is not the most preferred affordable bundle, and it is not a sufficient condition, though it is necessary but not sufficient. Okay, so this is how you have to understand again. The complementary case commodity, we have already seen that you have a ray, and in that ray your marginal rate of substitution at that point is infinite. Same for the other one, it is zero because you don't substitute. So on one side you have an infinite marginal rate of substitution for x1 and x2 because it is given, and you will go for any number of amount. On the other side it is actually zero because you don't, at only one point, you, that is x2 is equal to x1 point only you prefer. So uh, marginal rate of therefore is undefined because there is no substitution in that particular point. Okay, so which is the most preferred and affordable bundle? I think the most preferred and affordable bundle is the green dot. Okay, that is x2 star is equal to x1 star. That is b1 x1 star plus b2 x2 star, which is equal to m only at that point, and x2 star is equal to ax1 star. Okay, and x2 is equal to ax1 in that context. So this is about the complementary case. We have already seen the complementarity and the logic and the common sense of complementarity. We have already understood. So in the beginning itself. So no need of going further details. Intuitively, it is clear to have B because we don't want to spend money on something that cannot raise my utility. So this is the logic where you have this x2 star is equal to x1 star, because definitely that is not going to add on anything. So substitution from b to x1 star in a gives you p1 x1 star plus p2 x1 star, which is equal to your m, which gives exactly the same thing which we have already seen in the case in the complementarity. X1 star is equal to m by p1 plus alpha a p2, and x2 case you have an am by p1 plus ap2. So this is what is actually given here, and the expression which I said earlier is exactly you can replace in this graph, and you see that on the left side for x2 you have this equation, and for x1 you have the x1 optimal equation. So it, in that sense, it is trying to give you only one point where you can actually satisfy. Therefore the substitution is undefined, or you indeterminate. Okay. So complications of marginal rate of substitution condition. Let us recall the marginal rate of substitution is equal to p1 by p2, as price is the same for all individual. Every individual has the same marginal rate of substitution for optimal consumer consumption bundle, even if they have very different preferences. So it can be interpreted as a social willingness to pay for good one in terms of good two. So that is what is called the marginal rate of substitution. Now once you have all this thing in place, then definitely now your choice being made. So this is what is actually the sum and substance of the lecture. So let us look into the summary that is in the chapter or in the variant. What we are going to read is to put together budget constraint and preference together to analyze consumption decision. Typically, if we have interior solution, then the optimal condition is marginal rate of substitution, that is MRS is equal to P1 by P2. It can also have corner solution if one good is not consumed at all. And the next lecture, I think I'll go to different aspect of it. Thank you for your patient listening, and I think I'll stop the lecture and let us go for the question answer session in that sense. So if you have any question,